How's it going, everyone? Welcome, Euler Gonzalez. That's right. So today we're going to make a quick recap of how do we get here, especially on functional programming, to explore, see, and understand, as well as to improve my communication skills, and therefore finally have a more practical approach when we need to apply this set of tools when we write code. And I really love this course, or at least the approach that Kyle Simpson took, which is a very more hands-on approach from JavaScript developers. Those who come from an imperative language, this powerful scripted language that allows to provide interactivity to our applications, but also is to now handle the concurrency in this distributed computing, right? Now, since the idea is that by looking at this set of tools that we're going to apply in our everyday life, not only for JavaScript, but also for another programming language, because at the end of the day, the goal of this is to understand the conceptual aspects in JavaScript of functional programming, so we can make our programs much more readable and less error prone. Why is that? Because since this is now based on the foundations of the mathematics, pretty much like when you go out to a restaurant and at the end of the dinner, you get a receipt, you get a bill. You don't need a mathematical proof of the arithmetic that you're gonna do, whether it's the addition, the subtraction, multiplication, or division. Is that, hey, what is the total of this bill, and how much do I need to share if you go for example, with your family or with friends? You don't need to do that. You just use a tool, apply that, and now that's exactly the end goal of this functional approach or functional programming. The great news is not only that we can rest on the bedrock of the mathematics, which is something that a lot of functional programming actually find joy in, to go into this mathematical proof, which is something that I am not quite there yet, but by looking and exploring how you can use this kind of tools in the language to write these kind of applications, it'll make your app much more easy to read, which is perhaps 90% of the time that what you're going to do on the job is reading someone else's code, or even your own code at some point in the future. So you can now make some improvement or fix or even debug the applications. So the value proposition of functional programming is not only that you don't need the mathematical proof of each one of them. You can rest assured that this now lies on the mathematics, and therefore the only thing that you need to do is to apply that, see how that works, and what are the most common scenarios where we can use that. Now, because there is a little background here to understand how do we get here, I'm not going to explore that, but over the couple videos or the past videos, I have looked at this little bit of history to understand, is at least from the software architecture perspective and the computer perspective, how do we get here? This, luckily for us, this is something that now is on YouTube, is freely available. Grady Butch actually eloquently described this story of computation, which initially began as the companion of work, And after the revolution and specifically the Second World War, it becomes now an instrument to wage war. Until right now, that this instrument has become something that allows not only, especially with the rise of the internet, allows now is to connect with others. And this is something that is beautiful about, at least, of the internet. Yes, despite that it can create our own silos, our own echo chambers, but also it allows to connect with others and therefore act accordingly. Now, with the history of computing is now the way of how we tell these particular machines or this set of atoms to work or to do something that we need to do, right? And therefore there are now something that Grady Bush mentioned is that the history of software architecture is the one of rising up, is a history of rising above level of abstractions. So this is true because most of the time we as developers, we don't need to go down deep into the binary code. We just only use the assembly. We just only use high level language abstractions that those low level language, what it does is to move register or to change register and to store data in order that allow us to actually be more descriptive when it comes to, for example, build user interface in the case of JavaScript. All of these small buttons and giving interactivity and provide style to this. Or when you want to now communicate to a different part of your inner computer or other computers, what are you going to do? So for example, if I want to save this locally, this is the action that I want to do in my local machine, so I need to communicate with a particular peripheral that allow me to now store that data locally, right? Or perhaps I want to send an email, right? So now I need to communicate with another computer that is going to store on their side those messages or those emails. So the TLDR of this, okay, is that similar or those who starting to develop this kind of software or how they can decompose systems through algorithm, which is the procedural and versus the functions, and therefore now in the 80s there was now a different look at how you can now construct and build and design systems. So not only through processes, but also is through atoms, and that's why we have now classes. And even though that they heavily emphasize on inheritance and that creates all kind of weird abstractions, the value proposition of this is that each one of those paradigms allow us to now describe the world to make now much more easy to maintain our applications, debug, add features, or fix. So since this is the entire goal, and this is also the goal of the enterprise UI development, hey, we want to know, based on this legacy huge giant code base, at some point we want is to now is add features, do a refactors, or add features, do a refactor, fix some bugs, or run a migration without the fear of breaking something. So and imagine that also you need to collaborate and contribute with a wide range of people. So that's why now it's more important than ever to at least look at this paradigm, okay, when those paradigm has been used, and then take advantage of this. So for example, here on the functional programming is heavily used on defining its user interface, especially on React. So therefore, we're going to see how now this particular paradigm help us to do this. Also on the API as well. Perhaps some APIs or some servers are using behind the scenes language like Java or PHP or Python or Ruby, which is now heavily object-oriented programming. So we have now these two paradigms on how they're going to fit together. So for example, if you have ASP servers or Java, and they now need to combine that with React or Angular. So, but in any case, the point here is that this is what we need to do, right? This is what we're going to start is from the JavaScript perspective, not from the top-down approach, which is something that a lot of this functional programming comes. It's giving you the mathematical approach, and then you give you now a practical approach. So we're going to start with what we know, and then we slowly and progressively move to knowing something in the pit of despair until you push long enough to see how you can apply those. So the imperative approach and the declarative approach, the TLDR of this is that imperative is the way how do you describe stuff one after the another. So even though that this is machine efficient, but the cost is on readability, and not to mention that is hard to debug, understand, improve, and fix, especially when it comes to another developers. So with declarative, is say, hey, the only thing that I really care about is the output and why this function does what it does, right? So your comment should not duplicate the narrative of your code, since your code is telling a story, and that's exactly what it is. Now, another thing to mention here in the functional programming, according to Kyle Simpson, is that the code is provable. Again, we don't need the mathematical proof from using all of these techniques. You just want to know is, we can rest assured that all of this stuff now lays on the math, and therefore we can now spend less time knowing how to fix stuff and more times on what is important, which is the business, right? And of course, let's go to it. Because if you follow all of these mathematical principles, and if you can imagine a code base that has all of these mathematical principles, that you can rest assured that they're going to do what it's supposed to do, and you can now focus your attention to what really is important. So it's like you see a bill, you now do some basic arithmetics, and then you actually now pay that bill. Pretty much here with this, if you follow now this mathematical principles that actually are going to do what it does, they're going to give you that output and they're going to tell you why. You just can only focus on writing is now what is important, which is the business logic. So yeah, this is part of the course overview. So we're going to look at first a function, describe what function is, then closure and other basic components and crucial components of function, because with that we weren't able to actually go further. Then composition, the immutability, all right, the recursion, very scary topic for a lot of people, but actually they're not. They have their use cases. Then is where we're going to look at the map filtering, all of that kind of structure. How can we now deal is with sequence of data or a series of eventual value, which is something that I'm quite familiar with in this list map or in this functional array like style, right? And then some functional programming libraries that help you to do this. So by looking at the function purity and the difference between functions and the procedures, most of our applications are now or we wrote functions, but the reality that we wrote or we write is procedure. Why is this? Because the difference between a function and a procedure is that now those functions is that procedure actually takes some inputs, all right, but it doesn't return necessarily anything. Where unlike functions, to be called as a function, even though that you might have example like this, that hey, I'm creating this function, but it's returning another function, and that function doesn't return anything, you know. So just to make it simple here, okay, a function is something that receives an output and transform that to return an object. So not only that function is that, right, that the difference between functions and procedures is that a functions now receive an input and returns an output, is that what are the input that it's going to receive, or it cannot, or it may not receive anything, but what is the relationship between its inputs and its output? And this is now the way of how you can map in stuff, which is, hey, function name semantics. This is how you can now set a label to this function based on the relations of the inputs and the outputs. So this is when we look at this mathematical function here, or this mathematical approach, because it's whatever data input that you give, whatever data point that we receive, that's also why now the functional programmers call all of the arguments data points, okay, because it's going to create this relationship with the output. So whatever data point that we receive in this case, it will now transform into an output, okay. So functions, or the semantic relationships, so the function name semantics is that functions, the semantic relationship between input and computed output. That's what a function, at least in this context, is all about. It's a semantic relationship between the is the semantic relationship between the input and the computed output. So, for example, in here you have now this function that receives all of these data points, and that is now a relationship, close relationship of the computed output. For example, like this, and speed, you know. So function is the exact. So you have a lot of functions in your code, but most of the time what you have are procedures, which is, again, if you inherit all code bases that now use, for example, is object-oriented programming, a lot of the time you might have now stuff with that. So how many of you, when you look at the name of those function, can tell what the function does? That's what you need to have. So this is now, look at with these sunglasses. So it's like you have your now special sunglasses. When you look at the code around and asking these questions, it is a semantic relationship between what I'm putting here and what I'm putting out, and this is when you starting with your journey to develop this now sense here. Okay, and again, you're not going to develop this sense in one series of course or two or in a week. It might take you time to actually pondering into this, into all of this content. Now, finally, let's get into this, right? We talk about is now function namings, and let's get into talk about side effects. So I'm gonna get this right, which is semantic relationship. So anytime you're going to now have a functional approach, because now you have these special sunglasses. One of them is for the functional approach, the functional patterning, and the other is for the obviety patterning, right? And you are going to decide when to wear it. Okay, sometimes you might need the FP or the OOP, right? And FP is functional programming, and OOP is object-oriented programming. But when you put your FP sunglasses, what you're gonna look is the relationship between what I'm putting in and what I'm putting out. That's all about. That's all about. Okay, so let's get into this. Let's get into this.
Okay. So what we're getting, how many of you heard the term side effects? Okay. So what we're getting at, what we're scratching at here, is that in functional programming, for there to be a function, it's got to not have side effects. What does that really mean?
So side effects. So in order to be a function, this must not have a side effect. And this is why, for example, you now, again, this is also true when you look at the UI interface. For example, in the case of React, especially on React, because when you want to now test that component that at some point needs to talk with external systems, all right, whether it is by using an effect, or with other words, an effect is just a way of how you can synchronize with external systems, even though the naming in itself, it tells you what it's doing, or at some point you need to is talk to the store, the centralized place of where you're going to now store all of your needed data in a Redux. So for example, users, if you're building an e-commerce, for example, users and analytics, and catalogs of products, you know, all of this stuff that is going to be whole in that state, so you can now quickly retrieve that data and then do some manipulation and then do transformations of that. So in order to be a function, this must not have a side effect. But most of the time, this React component actually have that. And there are some particular patterns that allow us to replicate that behavior, known as the test provider. When you wrap this React component into a provider, that this function now has everything that it needs to. So it creates now an effective pure function. However, because this is not the way how you can test your app in the real world, since what you're doing is this component testing, is at least it's just to make sure that this UI works as expected. But in the bigger picture, you need to now integrate all of these different user interface into something that now users will expect to use. And that's where we look at the E2E testing with Playwright, and why Playwright now fit, and how does Playwright fits part on the entire UI development, since this, it allows you to now is recreate and actually test your app end to end by actually now running is a browser. You can specify at least 3 browsers. You can go. You can specify as Firefox, Chrome, and Safari, as well as the mobile, if you need to, or if you want to, and then elaborate, and then now with tools like pickup locators that allow you to now easily to click now, or that allows you to easily select elements in this component testing notations using the testing library. And I think this is quite interesting. And how do you put it? And also allow you to now record your tests and define now all of the steps by generating the code, so code generation with Playwright. This is also another reason why a lot of these companies are actually using Playwright, because this was designed and developed by Microsoft. But in any case, here we are talking about side effects. Okay, I am quite familiar with side effects, but let's take a look and hear what Kyle Simpson has to say about it.
That word gets thrown around, the term gets thrown around a lot. What do we really mean by that? Well, it's more than that. Number one, if I were to write a function called shipping rate, you notice, number one, right off the bat, you notice it doesn't have any parameters. And also, you'll notice that it doesn't have a return keeper. It does, however, still do a thing with some values. It takes a size, a weight, and a speed, and it calculates a rate. So on line 5, 6, 7, and 8, we set up those inputs and output variable. We call shipping rate on line 9, and on line 10, we legitimately got a shipping rate. This code will work all day long. And this code actually is a lot like most of the code in most of our apps.
Mm-hmm.
It's using some other stuff around it, and it's affecting something else somewhere else in the program, and it accomplished our end goal, which is that it got us a shipping rate, which is fine. This is not a function.
Mm-hmm.
And you would say, well, you just told me on the previous slide that if there's a semantic relationship between inputs and outputs, it's a function. Well, yes, that's part of it, but we have to keep evolving our definition. That is a necessary component, but it's not sufficient as a definition. Because not only must there be a relationship between the inputs and outputs, but the inputs and the outputs, to take advantage of the map that we're benefiting from the functional program, the inputs and the outputs are correct.
Mm-hmm. So to take advantages of the underlying math, the input and the output needs to be direct.
If the inputs or the outputs or both are indirect as they are, then it's not, even though there's a semantic relationship. So when we say side effects, what we really mean is indirect inputs or indirect outputs, or both. Some people like to call indirect inputs side causes. It's like cause and effect. Maybe that's useful. I like to use the big umbrella term, side effects. Side effects are both side causes, side indirect inputs, and potentially indirect outputs, affecting things outside of it. You'll have to trust me. I can't even really explain it. The math doesn't work if any of the inputs or any of the outputs are indirect. It doesn't work. So in a sense, we could twist the Rubik's Cube around and say, well, it's got to take direct inputs, aka argument constants, and it's got to compute and return a value without assigning to anything outside of itself. It can't access anything outside of itself, and it can't assign to anything outside of itself. That's a clear and solid way for us to avoid the whole side effect thing. That should make it close. Getting closer. Those are necessary components. This is side effects. We want to avoid side effects because side effects invalidate the idea of we don't get functions, we get and by getting the benefits, I don't mean that we can't use the APIs. We can definitely use the APIs. What we don't get is we don't get the provability. We don't get the verification, the security of knowing that this thing is definitely going to do what we want. It's kind of a waste of time to go through all the motions as if you're doing functional programming and not get the real benefit out of it. Not only you don't get the benefit, so that's why when we make shipping rate and we pass in the inputs and return an output, we call shipping rate with some inputs that we assign in this case to the rate variable, the output. That's
Mm-hmm. relationship between input and output. Therefore, changing the state of the app, exactly. Therefore, changing the state of the app at some point. Exactly. Therefore, changing the state of the app in an unpredictable way, which is why avoiding side effects exactly give us the ability to make our code provable. That it does what it's supposed to be. That it does what it must. That it does what it must to do.
It's direct, but semantically related to direct object. But I want you to
Mm-hmm.
And by the way, what I'm about to say, I can only speak to JavaScript since that's the context of JavaScript. I'm not saying anything about functional programming in a general basis. But I am going to tell you that in JavaScript, this much I can say, there's no such thing as function. There's such a thing as a function call. That for us to have the definition of a function isn't the important part. The important part is that that function was called on line 7 and gave direct inputs and got a direct input and that output at that point. That's the important part. It is the function call that matters. It is the characteristics of that function call that matter. Are there direct inputs and direct outputs from this function call? That's the question. Our temptation is to look at the definition of the function and try to answer that question. But it turns out, because of the nature of how JavaScript works, we cannot fully answer the question, is it a function, without looking at the function. So the important thing to talking about function, whether it is behaving as a function or other behavior as a function, the important characteristic there is not the definition of the function, but the call. The call needs to avoid creating or using side effects, and it's sort of indirect that the definition of the function is that way. The temptation is to think about the function as the call. We want to avoid those side effects with function calls rather than with procedure calls. So we use function calls to avoid side effects, but that's only a possibility, because not all side effects will be avoided. That's the function. Let's talk about side effects. What really are the side effects that need to be considered in the procedure calls? So we use function calls to avoid side effects, but that's only a possibility, because not all side effects will be avoided. That's the function. Because not all side effects will be avoided. That's the function. Let's talk about side effects. What really are the side effects that we need to be concerned about? We saw one kind of them, which is variables outside of the function. There's more to it than that. It's more than just a variable. For example, any sort of I/O, printing to the console, reading or writing from the file system, any of those I/O kinds of things put out there, those are all side effects on the system. So functional programming says avoid them. Those are out. Database storage, that's a side effect. Functional programming says that's out. Network calls, reading and writing from the DOM, timestamps, generating a timestamp, that's a side effect. Generating a random number, that's a side effect. So all of a sudden you start to think, wow, that's a lot of things. And our program that are side effects. And functional programming seems to say we have to cut all of those things out. But the fact of the matter is you can't cut all of these things out, because even if you think about it in a theoretical sense, any program that runs is going to be executed by the state. That is a side effect. It is an observable change to the state of the system. As a matter of fact, not even just the heat of the CPU, just the observable delay in time where one program can run because another program is currently running. That's a side effect. Not only is it practically impossible to avoid all side effects, it's also theoretically impossible. So when we say avoid,
It's not only theoretically impossible, it's not what nature you expect. It's not what the reality of how do we handle it right now.
program that had no side effects,
How do we perceive stuff?
if it could exist, a program with no side effects would be indistinguishable from the absence of that program. You couldn't even prove it existed. You couldn't send anything into it and see anything come out of it, so you couldn't even prove that it existed or that it didn't. So we really want to change our mindset from the side effects are bad to side effects take away the benefits of why I'm doing functional programming. They reduce, they water down, they impurify the benefits of functional programming. And that's why, if we're going to do side effects, which we have to do something, we want to make sure that they are very obvious. We want to make sure that we are very intentional about them, rather than simply not caring about side effects. So there really is no such thing as no side effects. It's just that we want to avoid them where possible. And when we have to, make them super obvious. Why do you think it would be important for us to make them obvious? Well, let's think back to what I said in the outset of our course. We said that code that is written with functional principles is based upon mathematics. And just like we don't have to prove to ourselves 1 plus 1 equals 2. If you have a set of your code that is written with functional principles, and then you have a bug in your program, and you could have the bug in your functional part, or it could be in the parts that don't abide by functional principles. Where is it far more likely to be bug? It's in the place where you're citing. I love the way a functional programmer describes this. They will describe this idea that we collect all of our functional programming stuff, all of our pure functions, we collect all of that stuff together, and we would sort of visualize like a sphere. It's the core that is functional. And then we collect all of the side effects, all the non-pure stuff, on the outer shell. Make a clear delineation in our program. I've gone so far, this sounds silly, but I've gone so far as to make a file called sideeffects.js and put all my side effects in that one file. Because if there's a bug, it is vastly more likely that it's where the side effects are. It's more likely that I got 1 plus 1 equals 2 correct, and then I messed something else up with not that. I got an algorithm wrong, or I used the side effect wrong, or something mutated the way I wasn't expecting. That's where bugs are more likely. You couldn't even prove it existed. You couldn't send anything into it and see anything come out of it, so you couldn't even prove that it existed or that it didn't. So we really want to change our mindset from the side effects are bad to side effects take away the benefits of why I'm doing functional programming. They reduce, they water down, they impurify equals to correct, and then I mess something else up with not that. I got an algorithm, or I used the side effect. So these pure functions that we're talking about, what does that mean? What do we mean by a pure function? Well, the first way we can define a pure function is, as we have defined so far, it is the function in the spirit of functional programming. It is a function that takes all of its inputs as direct, all of its outputs as direct, and it has no side effects. This is the first way of thinking about a pure function. But remember, and we'll come back to this in a bit, remember that I pointed out, it's not about the function that we
So that'll be all for this video. Take care. Bye bye.